Oh, Peter had a question if you uploaded the video from yesterday already, or are you going to do that?
No, it didn't work. Um, I think because I logged back in too fast. After I logged out, it didn't have a chance to start the recording. And so it never downloaded. And so I'm probably gonna have to go back and create a new video. Um, so yeah, but that's where we're at.
Okay, thanks.
Uh-huh. Trisha, can you read this one?
Shoot, sorry. Passing arguments. There are three ways to pass arguments to a method when the method is called by value, by reference, and as output. By value copies the argument's value into the method's formal parameter. Here we can make changes to the parameter within the method without having any effect on the argument. By default, C# uses call by value to pass arguments. The following example demonstrates by value. And then in this case, X is the parameter of the square root method and A is the actual argument passed into the method. As you can see, the square root method does not change the original value of the variable as it is passed by value, meaning that it operates on the value, not the actual variable.
All right, go ahead, answer the first question. All right, what is the output of this code? It's 5 because we've got main and um, we pass in A, which is equal to 5 for test, and then we have a console write line A. Well, A never changed, like passing it in and making the value of X equal to 5 and then never using it, that doesn't matter. So A stays 5. Jacob, can you read this one?
Passing by reference. Pass by reference copies an argument's memory address to the formal parameter. Inside the method, the address is used to access the actual argument used in the call. This means that changes made to the parameter affect the argument. To pass the value by reference, the ref keyword is used in both the call and the method definition. The ref keyword passes the memory address to the method parameter, which allows the method to operate on the actual variable. The ref keyword is used both when defining the method and when calling it.
So by doing it this way, you're able to basically pass the variable um, into here and change the value of it. So here, since we pass in a, not just passing in the value, passing in the actual variable with reference, because it's referencing that variable, then it's actually changing it. So that's the difference. Any questions on that? So if you don't do ref, it's not gonna affect it. If you do ref, it's gonna change the variable. Long story short. All right. Go ahead, start the practice, and raise your hand once you're done. Yep. All right, most of you are done. So, Brian, do you want to share your answer?
Sure, hold on. All right, I just broke the formula down in X's and Y's. So what I did was increase using the reference, the salary and the percent. And then down here to the static void increase. And then I told them pretty much X and Y what it was, and my formula is underneath. Let me see if I can't get it without doing it. Right here.
Okay. Good. Did anybody do it a different way? Okay. All right. Well, good. Well, moving on. Okay, fill in the blanks to create a method that swaps the values of its two arguments, ref int x, ref int y, and then we just make x equals y and y equals temp, which was x. So, Jacob, can you read this one?
Passing by output. Output parameters are similar to reference parameters, except that they transfer data out of the method rather than accept data in. They're defined using the out keyword. The variable supplied for the output parameter need not be initialized since that value will not be used. Output parameter are particularly useful when you need to return multiple values from a method. For example, unlike the previous reference type example, where the value 3 was referred to the method, which changed its value to 9, output parameters get their value from the method 5 and 42 in the above example. Similar to the ref keyword, the out keyword is used both when defining the method and when calling it.
Okay, so this one, you're able to change or to set values that you're going to output, basically. Pretty straightforward. Any questions there? Okay. Go ahead, answer the last question. All right. Fill in the blanks to ask for user's input in the method and return the value entered using output parameters. So first we set it as an output parameter and then get the data and then output the string that was created here to set the value to whatever the user input up here. All right. Roger, can you read this one?
Method overloading is when multiple methods have the same name, but different parameters. For example, you might have a print method that outputs a parameter to the console window. The plus operator is used to concatenate values in this value. The value of A is joined to the text value. The method accepts an integer argument only. Overloading it will make it available for other types, such as a double. Now the same print method will work for both integers and doubles.
All right, go ahead, answer the next question. Okay, method overloading means same method name, different parameters. Sandra, can you read this one?
Of course, overloading. When overloading methods, the definition of the method must differ from each other by the types and or numbers of parameters. When there are overloaded methods, the method called is based on the arguments. An integer argument will call the method's implementation that accepts the integer parameter. A double argument will call the implementation that accepts a double parameter. Multiple arguments will call the implementation that accepts the same number of arguments. As an example, you cannot overload methods declaration that differ only by return type. The following declaration results in an error in print name, blah, blah, float, print name, double. Overload and complete the given method so that it will calculate the required amount practice.
All right, so with Python, you would just name things like you'd have one version of print, right? Well, here you can have multiple versions that just take multiple different types of values like string, double, int, whatever, and you can name them the same thing and just take different values. Any questions there? Okay, go ahead, start the practice and raise your hand once you're done. And make sure not to use the C solution. All right. So a lot of you are done now. So, Trisha, do you want to share your answer?
Oops.
Okay. Are you seeing my screen?
Yeah, but I'm seeing your Visual Studio.
Oh, sorry. Here.
No worries.
So I did from the previous lesson where you add in here the int A and then int B because we have two integers we're trying to add.
Uh-huh.
And then down here, double A and double B because again, there are two. So I added that and then just did return A plus B on each.
Oh, good. All right. Did anybody do it a different way? All right. Is anybody still struggling with it and needs help? Okay. And moving on. What is the output of this code? So we've got int A is A times A, and then double A is A plus A, and then print 3. Well, print, well, the 3 is an integer, so it's going to do this one, and then do 3 times 3.
Okay, 3, so it's 9.
Okay. Recursion. All right. So, let's see, who has it read? Will, can you read this one? Will, are you there? I think he said he needed to step away. Mark, can you read this one?
Recursion. Recursive method is the method that calls itself. One of the classic tasks that can be solved easily by recursions is calculating the factorial of a number. In mathematics, the term factorial refers to a product of all positive integers that are less than or equal to a specific non-negative integer n. The factorial of n is denoted as n, for example. Recursive method is a method that calls itself.
Okay, and we just covered recursion with Python towards the end of the class, so hopefully that's still fresh. Oh, should I give you a chance to do this one? What's the factorial of 5? Well, it's 120 because it just is multiplied down the chain. All right. Tim, can you read this one?
Yes, recursion. Good afternoon. As you can see, a factorial can be thought of as repeatedly calculating num, all. Num1 until you reach 1. Based on this solution, let's define our method. And then you get that. In the fact recursive method, the if statement defines the exit condition, a base case that requires no recursion. In this case, when num equals 1, the solution is simply to return 1. The factorial of 1 is 1. The recursive call is placed after the exit condition and returns num multiplied by the factorial of n minus 1. For example, if you call the fact method with the argument 4, it will execute as follows. Return 4 all fact, open close parentheses 3, comma, which is 4 all 3 all fact, open close parentheses 2, comma, which is 4 all 3 2 fact, 1, which is 4, all, 3, 2, 1, with all in between. 4, all, 3, all, 2, all, 1. Now we can call our fact method from main. Try it yourself. The factorial method calls itself and then continues to do so until the argument equals 1. The exit condition prevents the method from calling itself indefinitely. Recursive summing practice. Thank you.
All right. So, any questions on this? No? Okay. All right, go ahead, start the practice and raise your hand once you're done. Oh, and don't use the C solution. Okay, seems like some of you got it now. Somebody who's still working on it. Jacob, are you still working on it?
No, I'm finished. I'm sorry. I forgot to put my hand up.
Oh, okay. Peter, are you still working on it? Oh wait, you need to go to work. He's getting caught up.
Yeah, I'm here, but trying to get a way to catch up on other things.
Yeah, no worries. Okay. We'll just go with somebody who's
But
done. Mark, you want to do screen share?
All right, can you see my screen?
Uh-huh.
So I did if num equals 1, then the brackets return 1. Then brackets again, then I did return num plus sum num minus 1.
Good. All right. Good job. Anybody struggling with that one or having questions? Nope. Okay. Right. What prevents the recursive method? What prevents the recursive method to call itself forever? It doesn't seem grammatically correct. But anyway, the exit condition or the base case. All right, that's a good spot to end for today. I will be right back.